Technology is really cool now.
Alright, we are having a quiz tomorrow. Woo-wee. Are you excited? Okay, we've had some funky weeks with OSP testing and stuff, so we're just going to sit and go through these one at a time together. This is your quiz, almost verbatim. The formatting, the types of problems, the only difference is the numbers have changed up ever so slightly. Okay, so no big surprise that we even have an extra credit section at the very, very end. We get there, we get there. If not, still an opportunity to get some points back. The first 4 problems are all about your calculator. Okay, it's the beginner level of these problems. It's just being able to evaluate, which is find the number that is equal to the log. Number 1 and 2 are easy peasy lemon squeezy, as easy as it gets. 1 and 2 are all with the calculator. All with the calculator. So probably good to take it out and get this done. Okay? So we pull up our calculator. Number 1 is log of 12. Do people remember what base this has when it doesn't have a number there? 10. Close. 10. When it's a log and there's no number, it's log base 10. And we're allowed to just use that log button next to 7 on the calculator. We just have to type in log 12. Log, type in 12, and it's very important we close our parentheses.
1.07?
Yep, we click enter at 1.079. Now, it is important, and in math, people are a little petty and nitpicky. Logarithms always are written to the 1000th place. That means 3 decimal places. So 1.079. 1.079. That is it. That is how you evaluate a basic logarithm. Plug it in your calculator. Okay, now number 2 is super similar. Although instead of being the common log, it's ln. And ln has base, do you remember? E, base E. We also have a button on our calculator for ln, so we just have to type in ln 1 over 4. The ln button is right under the log button. ln 1 divided by 4. Close your parentheses. Click enter. And we're going to write down 3 decimal places. Negative 1.386. Yep. Type it in. Yeah, so the ln button, again, is right under the log button. It's kind of next to the 4. And then 1 divided by 4, parenthesis, enter. Negative 1.386. That's it. Done. Those are your first 2 questions. They're going to be us figuring out and you telling us if you know how to use the log button on your calculator and the ln button. Okay? The only difference is we switched up the numbers on the inside a little bit, but make sure you can type those in. Now, it gets just a tiny bit trickier with 3 and 4, but just a tiny bit. If you look at number 3 and number 4, what's a little different?
There's a 2.
There's a base of a 2 and a base of a 1/4. Now, we can't just type in log 81. That's different. We can't just type in log 101 because these are not logs with base 10s and they're not ln's. So we have what's called the change of base formula. Okay, we're going to do it both ways. We're going to do it the old school change of base way, and I'll also show you the little bit cooler trick we can do with our calculator. So the change of base is just a simple little way to rewrite a logarithm so we can use the log button on our calculator. You are always going to take the log of the inside and then divide it by the log of what your base is.
2.
So we're going to rewrite it as division. Log of 81 divided by log of 2.
Do we close the parentheses on the first one?
Yes, super important. Okay? I always remember base on bottom. Remembering base bottom. The value, the 81's on the top, the base is 2, so the base goes on the bottom.
6.339.
Does that sound about right? It's going to go real smooth. Yep, we're going to type it in. So, if I'm typing this in, I'm typing log 81, and yes, this is the scenario where if you do not close these parentheses, you will not get the right answer, because you have to tell your calculator to stop the log before you divide.
I thought you pressed log.
That's another way. Log, because it depends on the problem. On number 4, when it's a fraction, that way doesn't work. So you have to know both. Log of 2. And click. And you get 6.339, but when we round, 6.340. 6.340. What's wrong? Okay, so that's the old school way of doing it. And that works a lot of the time. The change of base always works. The new school way works most of the time, not every time. We're going to do it just to show you. Three, 9, and then what number? And what does the 8 do? Bumps it up. That's how you round. Okay, so, like Olivia said, there is another way to do this. We're going to do it just to show you. It works most of the time. If you click the math button and scroll down, you will eventually see an option called log base. And this lets you actually put in a log of any base. Now the downside to this is you can't plug in 1/4 and like look at number 4. The base is 1/4. You can't actually plug in a 1/4 in here. So this way works most of the time, but not all the time. So it's good to know both ways. So we can just type in 2 and type in 81 and click enter. We get the same thing, 6.340, Yep, so look, that's also an awesome way to do this problem. Okay, now the reason why I show you both is because in number 4 we have a fraction as a base. And our calculator gets upset when we put a fraction in using that newer method. So when you see a fraction, you kind of have to use the change of base way. So it's good to know both. If you want to just do the change of base, that's fine, but make sure you kind of know both. So it's the log of the inside divided by the log of the base. Base for bottom, so 1/4 on the bottom. Base bottom. And again, as long as you remember to close your parentheses, you just type it in. Log of 101, close parentheses, divided by log of 1/4. Log of 101, close parenthesis, divided by log of 1 divided by 4. Enter. Negative 3.329.
Do we round up? No. Oh, yeah, we do. 3.
That's the last one of these calculator ones. Yeah.
3.
So what happened?
Yeah, the first one is just writing the total change.
3.330.
Oh, okay.
Down because after the 9 is just a 1.
Oh.
Negative 3.329. Since the number afterwards was smaller than 5, we would keep it a 9. But if it was like 0.3296, then we'd round it to 30. Huh? Oh, it does work. It doesn't always work, though. There's certain things that don't work.
Do it right.
I'm going to write you a mean now. Okay, so that is the basics of logarithms. You're telling us, do you know or do I know how to plug in logs? Do I know how to plug in logs of different bases? Okay, but it's going to be just like that. Same format, same ordering of questions. Only difference is we change the numbers up a little bit. That's it. No surprises. Okay, so on to the second part of your quiz. The second part of your quiz focuses on being able to turn a logarithm into an exponential and vice versa. So I should be able to write a log down in front of you and you give it back to me as an exponential. And the other way around, I should be able to give you an exponential, which is the green, and you should be able to write it as a log. So that's what we're going to do for 5 and 6. We're just going to rewrite. And this converting formula is going to be given to you. You just have to memorize where things are and where they go, to be honest. So a good way is if we look at number 5, it tells us rewrite into a logarithm. Right now it's an exponential. It's in this green format. And we need to rewrite it in the yellow format as a logarithm. A good way to do this is to label each of your parts. So right now this is in the green format. So what's my B? What number here is my B? 2. The base is 2. A minus 3 is my exponent, or x. And b plus 4 is my y. This whole thing is my y. Okay? And now I'm going to rewrite it as a logarithm and make sure I put my b, y, and x in those right spots. So I'm going to have log. My b we said was 2, so base of 2. On the inside, we're going to put the y, which was b plus 4, the whole thing. And that's going to be equal to the x, the exponent, which was a minus 3. That's it. We rewrote our exponential into a logarithm. Done. Again, you're going to have that little formula. So whatever way works for you. We also sometimes talk about doing the loop-de-loop. If you like doing the loop-de-loop. Or whatever helps you get those things in the right spot, we're good to go. Okay, now we're going to do basically the exact opposite. We are going to find the inverse. Okay, right now my function has an ln, so it's a logarithm, which means I need to turn it into an exponential. So just like we did before, we're just going the other way. Instead of starting as an exponent and going to a log, we're starting with a log and turning it into an exponent. Now, the one thing we have to take care of is this yucky f of x. This f of x we're going to rewrite as a y. Y equals ln x minus 3 plus 4. Now, because we're finding an inverse, before we turn this into a law, or into an exponential, we want to flip the x and the y. Okay, we're just going to flip their spots. Inverse functions, all your x values become y values, and all your y's become x's. So by flipping them in the equation, it does that for us. So x equals ln y minus 3 plus 4. I see one issue. Why can't I start labeling my, my x, my y, and my b right now? If you look up here at the little formula they give us, is the log all by itself over here? It is. This is all the log.
Oh.
Here, is that true? What's extra over here? The plus 4. So before we should do anything, what should we do with this? We should move it to the other side. Get rid of it by subtracting 4. Okay? So before you start doing what we did over here, labeling your b, your x, and your y, make sure your logarithm is by itself. So x minus 4 equals ln y minus 3. And now the log is definitely all by itself. And now we can start labeling all of our parts and rewriting it. Okay. Let's start with our base. The base is the little number by the log, but what's our little number? It's e. ln automatically always has a base of e. So if you want to write a little e in there, whenever you see an ln, you can write an e in there. That's the base, e. So that's our b. Okay, the inside of the logarithm is called our inside. This is our y. Also, it's our y because what does it have? A y. Here, this is our x because it has an x, but that also follows our format. Okay, and now all we're going to do is put our b, x, and y in the proper spots. So, it's, why are we rolling? Yeah, question. Yeah, because this one is an inverse. It's just, this one's just more work, a little more work, a couple more steps. We're going the opposite way. This is the quickest way I can do it. So our base, e, to the power of x, what was our x? X minus 4 equals the y, and our y was, and look, it's now an exponential, and we're done. Just like your test is literally basically this piece of paper. Yes, question.
Where did you get E from?
ln always has a base of e, so e is our base. E is our b. Okay, any questions before we do the 2 on the back, and then we got it all? Okay. All right, 2 more. Oh, those are bonus. We'll do them if we have time, otherwise. Okay. On the back, 7 and 8, this is expanding and condense. Expanding and condensing. There are only 3 little rules you have to know. When 2 things are divided, we split them into 2 logs that are subtracted. When two things on the inside are being multiplied, we split them into two logs being added. And exponents always get put in front of the logarithm. Okay, we're in number 7. I made a problem that has all of the properties so we get to see and practice them all. So when I first look at this, what's happening? There's division. So we're going to rewrite this as two separate ln's being subtracted because it's division. So the ln of the top, this is, yeah. Okay, again, because we were dividing the 8y to the third divided by the 9z to the fourth, we rewrote it as two ln's being subtracted. The top went in the first one, the bottom went in the second one. That is our first step, yes. Okay, we gotta just keep going until we're as expanded as possible. The more logs, the better. Inside of this new log we made, what's happening? What's happening between these two things? Multiplication. Same here. This is multiplication. So we can split those up as two more logs, ln's, being multiplied. When two things are being multiplied, do we add or subtract? Add. So the ln of 8 plus the ln of y to the third. So that's split into ln of 8, ln of y to the third. Our minus is still there. Same exact thing. The second one's going to split. ln of 9 plus, because it's multiplication, ln of z to the 4. That's your second rule. So division, we split it and subtract. Multiplication, we split it and add. Now, what do I do with these? They come outside in front. So these pop out in front of the log, and then we'll be done. There we go. Inside each logarithm, there's only one thing, so we're done. Expanded. Okay. 8 is exactly the same thing, except in reverse. We're starting with a bunch of logs that we now need to all push together into one log. So we're going to use all of our same rules in the opposite order. Okay? So, if we're going in opposite order, the first thing is any numbers in front have to go back inside as exponents. So if I look here, I got a 2 there, I got a 3 in front there, I got a 1/2 there. All of these are going back into the inside as an exponent. We're putting them back inside, putting everything back together. Log of 3, putting the 2 back inside, plus log of z squared, minus, log of x to the third, and I know this is a fraction, but we still do the same thing, log of y to the power of 1/2. Okay, all of our exponents back on the inside. Put all of our exponents right back on the inside. Okay, now wherever we see a plus, we're going to push those logs together and rewrite the insides as multiplication. So like here, remember what we did? We had an 8 and a y to the third, and what did we do with them? Split them with an add. If we were going to backwards, we would just put them back together. So we're going to put these two pluses back together. Log of 3z squared. See, we just pushed them right back together. Yep, and then we're just going to rewrite everything how it was. Okay, now let's start dealing with our minuses. What's going to happen with these two? They're being subtracted, so they're going to become a fraction. These just push together and become a fraction. They're being subtracted, so we just put them back as division. These become 1. Log 3z squared over x to the third. Look, as we go, we have fewer and fewer logs. We're done when we have 1 log left. What's happening between these two? They're being divided. So where am I going to put this y to the 1/2 in the fraction? Just put it on the bottom. We're going to add this little y to 1/2 into the bottom. Log 3z squared is still on top. Still an x to the third on bottom. I gotta add in y to the 1/2. And look. Woo! Done. We're done because how many logs are there? 1. Done. And that's your quiz tomorrow. Just like that. Those 8 problems.